Hi everyone. Today we're going to be working on a project for exploratory data analysis and data storytelling. The project today is going to be about the NBA, and we're going to specifically be talking about shooting and win percentages between different teams across the league. So we've set up this notebook here. We'll upload this later for you guys to use, but for now we'll just run through it. We'll get started right now. So obviously the first step is going to be importing our necessary libraries. In this case, it's going to be pandas, numpy, and matplotlib for the visualizations. Let's just get into it. So first we want to import the data. So the way we actually did this is first we went to basketballreference.com. It's this great website that has a lot of data regarding the NBA and even the WNBA, I believe. And I think they have websites like this for football and baseball as well. So first what we did is we wanted team stats for a couple specific teams. So we just went over to teams. We picked some teams, like for example the Warriors, and we went to year by year stats, the basic stats. The stats we wanted were the wins, 3 point percentage, 2 point percentage, free throw percentage. So the way we got those is this is basically a giant table of everything that relates to the Golden State Warriors over their past 74 seasons of existence. So what we did was we clicked on share and more, clicked on get this as an Excel workbook. Basically, that opened up a Google Sheet for us, and we downloaded that as a CSV. We're not going to do that right now, but that's how we got the CSVs for all these 5 teams respectively. So, of course, once we have the CSVs, we use the pandas method to read them to the into our notebook, and we renamed them regarding each team. So let's just go ahead and inspect our data real quick. So as you can see here, for the Wizards data frame, we have the Washington Wizards team here, um, and all the other stats that go along with that. And then the same follows here for the Warriors. You might see the abbreviation is a little different here. That's because they used to be from Philadelphia, which is why the team abbreviation is PHW rather than GSW. You can also see there's a lot of NaN values back here because back in the 40s and 50s, they didn't keep a lot of these stats um, as well as they do now. And so a lot of these stats from the past seasons are kind of either missing or they're kind of useless. Uh, so yeah. So next we'll move on to the data cleaning step. So as you can see from this stuff, there's a lot of stuff in here. There's, season, league, team, wins, losses, uh, height, weight, the average height and weight of the players on the team, average age, and some. It looks like this was one random column here that's not really doing anything. So we can definitely drop a lot of these columns. Um, so we'll go ahead and do that in this step. So in order to make the process easier for each individual team, we just created a function so that you could just apply this function to each team individually and it'll do the same exact thing. So in this case, the first line is team win percentage. So as you can see, the original data doesn't provide the win percentage, although it does provide the wins and losses. So, that's a pretty easy calculation. We just take the number of wins divided by the total number of games they played, which is wins plus losses. And yeah, there you have your win percentage. The second thing is for season, it shows 1948 to 49, 1950 to 51, 2019 to 20. However, we want to reformat that so we can graph it a little easier. And so basically, we're just going to drop off the tail end here. So our new table will essentially have the year that the season started in rather than the full season name. So, for example, the 2019-2020 season will just be 2019 because that's the year it started in. 1948 to 49 season will just be called 1948. So just something to keep in mind for that. And again, the way we do that is we use a method here to split it. So we would split the string by this parameter, the dash character, as you can see here. And we want to, so what that does is it splits it into the 2 parts before and after that. And we want the first part. So for example, 46 to 47 gets split here. And we want the first element. So we take 1946. And that'll apply to everything there. This last method here is a little confusing to look at and maybe a little counterintuitive. All you need to know is that this essentially reverses the order of the data frame. So as you can see here, it starts off from 2019 to 20, and it ends at the very earliest year. This essentially just reverses that. It puts the earliest at the top. Again, this is used to make the graphing a little bit easier. And at the end, we're going to return these columns. So basically, we want to keep these columns specifically and in this order specifically. And that's what this last step of the function essentially does. So let's go ahead and run it, and we'll check the wizards frame. So as you can see, our data frame has been reversed. It starts off with the earliest season. We have added the win percentage column, and we have only kept the columns that we want. So it looks like that was a success. We'll move on to the Warriors data frame as well. And as you can see here, we're looking at the tail, and the tail has the very most recent season. Again, it has the win percentage as well, and the only the exact variables that we actually want. So it looks like our function has worked out pretty well, and we can apply it to all of the teams. So this teams array here is just an array of each team. It'll make it a little easier for something we're doing in the next step. We'll get to that in a bit. Alright, so now we have moved on to the data visualization step. So our first visualization here is called plot percentage. Basically what this is going to do is, given a specific type of shot, whether that be 2-point, 3-point, or free throw, and a specific team, we're going to plot that. We're going to plot the percentage of that shot with that team's win percentage to kind of see if there's some sort of trend or some sort of correlation here, whether that be negative or positive. So you can see we have two little kind of categories here with this if-else statement. So if shot equals all, basically that's saying if you want to look at all the shots, it'll plot the win percentage against 3-point, 2-point, and free throw percentage. Otherwise, you can specify a single type of shot, and in the else clause, it'll only plot that shot against the win percentage. So a lot of this stuff here you might recall from the data visualizations lecture, but we'll go through it really quickly just to give you a refresher. So these are the variables we want to plot, right? Win percentage and the varying shot types. And each of them, we want to have a different color line, and we want to choose the line. So for example, for win percentage, we're going to have that be black, and everything else is a different shade of blue. So that way you can easily distinguish which one is the line for win percentage and which one is each different type of shot. We add these labels here so that way the legend will show it. That's pretty useful, so that way you can actually distinguish it straight from the graph. So we'll go ahead and run this, and we'll create a couple cells here. We'll look at a couple of different visualizations. So our first one here is going to be plot percentage, wizards, and all. So as you might guess, this is going to plot the win percentage of the wizards against every single type of shot we have. So we'll go ahead and run that, and there you have it. So the black, as you can see from the legend, is the win percentage, and you can see that over here, and these are the varying types of shots. As you would expect, free throw percentage is the highest, followed by 2-point percentage, and then followed by 3-point percentage at the end. You can also notice that the 3-point percentage doesn't start until about a quarter of the way in. That's because that's when the NBA actually added the 3-point line. Before that, it didn't exist, and that's why there were so many NaN values for those categories. So let's go ahead and make a little more specialized visualizations. For example, we know that the Warriors are a very good 3-point shooting team in recent years, as well as the Rockets. So let's kind of check those out. So we'll look at the Rockets here, and we only want to focus on 3-point percentage. So instead of putting all, we'll specifically do 3-point percentage. Great. There we go. And we'll do the same thing for the Warriors. Nice. So as you can see with the Rockets, it looks like the 3-point percentage has actually kind of corresponded to their winning percentage. You can see their winning percentage over here has kind of gone up with their 3-point percentage, but then the trend sort of kind of flattens out towards the end. As you can see, everyone kind of regresses to the mean of average 3-point shooting. Same with the Warriors here. Looks like they didn't really start shooting threes that often until a little later than the Rockets did, and their percentage doesn't correlate quite as strongly as the Rockets do. We can check a different team here. For example, we'll check the Celtics, and we'll check their free throw percentage actually to kind of mix it up. and there you have it. So you can see their free throw percentage over here. This one actually, you can see a little bit of a correlation here. There's a little dip here that corresponds to a dip in win percentage. Same over here. This actually follows a little more closely than you'd expect. And then over here is where it kind of starts to not work quite so well. So we'll change this to all, and we'll check all their shooting percentages. And there you go. So this might actually be a little hard to read because there's so much going on this graph. But we can show different portions of it, whether or not we want to look at specific time periods or not. So yeah, we'll move on to our last visualization here. This one is going to be actually a bar graph. So this one, we are going to want to compare the shooting percentages and win percentages again, as we did before, but this time we're going to compare them with the other teams that are in our data set. So this one, our function, we're going to pass in the index and shot. So the index here refers to the year. So as you can see in our data frames, we have our index here. Each index corresponds to a different season, and the earlier the index is going to be the earlier the season. For example, the 0 index is the most recent season. The highest number index is going to be the oldest season in that team's existence. So here we have it. We have created our plot. So we have all our different teams in our X variable. Our first Y variable is going to be the specific type of shot percentage for each team. And the second is going to be the win percentage, which is going to be constant per season. So this stuff here is, if you're interested, you can look into it a little bit more. This stuff kind of just formats the graph, makes it look a little nice. It basically puts the win percentage and the shot percentage right next to each other, and it picks a different color for each thing, so you can kind of distinguish between the teams and between which variable is being plotted. This stuff here again is for labels and setting the ticks on the bottom. So again, kind of formatting stuff, which is important, but not the main focus of this video, so you guys can go ahead and check that out later. So we'll run this, and so the first thing we're going to compare is we're going to compare the most recent season 3-point percentage between all the teams. So we'll go ahead and run this, and there you have it. So you can see here that all the teams actually have a pretty constant 3-point percentage between all of them. It looks like, with some context, you might realize if you watch the NBA a lot that teams are shooting quite a bit of threes nowadays, and so everyone has kind of focused on improving, which is why so many of these percentages are so accurate and close to each other. So you can see how close they are to each other and how that doesn't really correlate to their win percentage. So maybe we want to check a couple years in the past. So we'll check the 2012 season right here, and over here you can see that there's a little more variation in the shots and a little more variation in the win percentages too. So let's go ahead and check 2-point percentage for the same year just to see what that kind of looks like. And we'll actually go ahead and put these two side by side so you can see the 2-point percentage and the 3-point percentage actually compared against each other. So perfect. So now, as you can see, the visualizations have been stacked on each other. So you can see here that the Warriors didn't have a great 3-point. They actually had a pretty good 3-point percentage back in 2012, and their 2-point percentage was pretty solid too, which correlates to how high their wins are. The Thunder, meanwhile, had a lot higher 2-point percentage, but a little bit lower 3-point percentage, which is why their wins are roughly at that level. And then you can see the Rockets and the Celtics kind of have less wins than both the Thunder and the Warriors, and it looks like their 3-point percentage is actually decently lower as well. So yeah, there we have it. This is our data analysis and data storytelling of the NBA data sets that we have. Again, we could have put in different teams and different years and whatnot, but the cool thing is that with the functions that we created for both the visualizations and for the visualizations and for the data cleaning, you just have to put in different types of variables, different names of teams and whatnot, and the work has already been done for you. So yeah, hopefully you guys learned something new from this video, and yeah, sounds good.